Hey everyone, Ethan Nader here with Horizon Hobby, and if you followed along with the Blade Fusion 700 build series videos on the Blade YouTube channel, then you will see that the Blade Fusion 700 is the ultimate first ever 700 size kit. Again, with the main rotor and tail rotor coming pre-assembled with Loctite, it leaves a lot of guesswork out for somebody who has never built a 700 size kit before. And again, whenever they decide to take the main head and tail rotor apart, they get to see basically how it was correctly assembled. So that's really nice as well. So with that being said, if you purchased a super combo Blade Fusion 700, then the electronic setup is just as easy as the build in terms of the flybarless system setup and also programming the Avian ESC. And that's what this video is going to be dedicated to, is essentially getting the Spektrum FC6350HX flybarless system all set up for the Blade Fusion 700 and also the Avian ESC. Again, there's no computer needed, no programming card needed. It is all done through the transmitter, and that's really nice as well. And then also too, we'll be explaining the bind process. So again, essentially getting your freshly built Blade Fusion 700 all set up and ready for its first flight. So a couple things to note, everything that you see here on the table, I'm going to be using. So I have the Spektrum NX20, which is what we are going to bind the Blade Fusion 700 to. I also have a digital pitch gauge. That's why I have the blades on here. Some pitch gauges, you don't require the blades, but this one you do. So I'm going to be using that with the blades. That's why they are on. And then also too, I have a bind plug right here, and that's going to be used to bind up the DSMX remote satellite receiver up to the FC6350HX. And then also I have some ball link pliers and also some regular pliers, and these both are going to be used for getting the ball links off if we need to make adjustments, and then also turning the actual linkages in order to lengthen or shorten them in order to properly get the geometry and everything set up in the main head and also the tail rotor. And then one thing over here on the Avian ESC, I have a boot plug connected, and that's essentially so then we can power up the ESC through just one 6S battery. It essentially makes things safer and less voltage. Essentially on a 12S setup, we're only going to be using a 6S battery. So again, it makes everything safer, and then also it makes it easier. So with that being said, that's pretty much everything that we need to cover before we get into the bind process. But before we go into the bind process, we are going to set up the NX20 with the appropriate settings for the FC6350HX before we start going into the forward programming and tuning it. So let's go ahead and get a model set up and configured for the Blade Fusion 700 on the Spektrum NX20. So with the transmitter on, we can go ahead and create a brand new model. So as you see here, I'm going to add a model, and for the model type, we want it to be a helicopter. I'm going to select create. And as you can see, we now have a created model. And if you want, you can go ahead and go down to the system setup, and then from there you can go to model name, and you can name this to Fusion 700 or whatever you want to name it to, where you won't forget which helicopter this corresponds to. Once you have the model named, you can go ahead and go back and go to the main menu. As you can see, the name has saved. Now we can press the scroll wheel and we can go all the way down to our system setup right here. We're going to select yes. Going down to our F mode setup, we want to make sure that switch 1 is switch B, and our hold switch can be assigned to switch H. So all you have to do is flip the H switch right here and it will automatically assign it, and we can press the scroll wheel to lock it in. Now we can go back to our list, and going down to our frame rate, we can now set this. In our frame rate, we can select the X plus and change it to inactive, since the FC6350HX flybarless system, we don't really need to use X plus on it. And we can also change the servo mode to hybrid like this. Back at the main menu, you can press the scroll wheel again, and right here we can go to rates and expo. Now this is all personal preference. Personally, I do not like to run dual rates and expo on a switch for helicopters. I usually just leave it set to on and the rates to 100%. But if you really wanted to, you could set the rates and expo on a switch and customize them however you want. I'm just gonna leave them to on, like you see here. And typically I like around 10% for aileron, 10% for elevator, and around 15 for rudder. Once you have your rates in expo set to where you want them to, you can select the list and go down to throttle curve. Now again, much like dual rates in expo, this is all personal preference. Typically, I don't run a linear curve like you see here. Personally, I like to run a flat curve on normal, stunt 1, and stunt 2. So essentially there is no 0% point on my throttle stick. It's all just a flat curve. So basically if I need to land, I will just flip into hold mode like you see here. But again, this is all personal preference. For the sake of the video, I'm going to just run what the manual says, and that is 0% on the first point and then 60% on all of the other points. So as you can see here, we have 60 on point 2, 60 on point 3, 60 on point 4, and 60 on point 5. So as you see, basically all the way down, if you are out of hold mode, the helicopter will not power on, but as soon as you start throttling up, the helicopter will want to power up and go to 60% where point 2 is at, like you see here. So again, whenever you need to land, you just flip into normal mode and basically lower your throttle stick and shut the helicopter down. So going to curve 1, we can set this curve, according to the manual, is 70%. So we are going to bump it up to 70 like you see here. And again, we'll do 70 for point 2, 70 for point 3, 70 for point 4, and 70 for point 5. Now again, this is a flat curve, so as soon as you go from normal to stunt 1, like you see here, your throttle stick will stay at 70% no matter where your throttle stick is positioned. So again, this is essentially just going to control pitch, and your throttle is going to stay at 70% throughout this entire travel right here. And again, for stunt 2, we can go ahead and change this to 80% all across. So much like on stunt 1, it is going to be the same in terms of not being able to really shut the helicopter off with the throttle stick, but you would have to either go back into normal and lower the throttle stick, or you would have to flip hold mode in order to shut the motor off. So again, this is going to be just a little bit more throttle on stunt 2. And we are going to set 80 across the board like you see here. And again, hold mode, you just want to make sure that it is at 0% like you see here. After the throttle curves are set, we can go back to our list and we can go down to pitch curve. Just a quick note, make sure you do not confuse your throttle curve and your pitch curve. Those are two very different curves, and you just want to make sure that you are setting up the appropriate curve based on what settings you're doing. But now that we are in pitch curve, since we are running a throttle curve that goes down to 0%, so basically somewhat of a linear curve on stunt 1, you don't want all that negative pitch going down and forcing a lot of pressure on your skids whenever you're trying to land the helicopter. So in order to counteract this, instead of having 0% on point 1, we are going to bump this up to 30. So that's basically going to give us less negative pitch on normal mode, which in turn puts a lot less stress on the skids and the helicopter itself whenever you're trying to land and you have your throttle lowered down here. Because again, this stick right here is going to correspond to throttle and pitch. So for point 1, we want 30%. For point 2, we are going to want 40, just like that. And then for point 3, we can leave it at 50, point 4 we can leave at 75, and point 5 we can leave at 100%. So as you see here, we have our normal pitch curve set. For stunt 1, stunt 2, and hold mode, we are going to leave these all alone. Again, because whenever you flip into stunt mode, you essentially want that full collective pitch range, whereas it is limited on your negative pitch range on normal mode. And going back to the function list, the last thing that we really need to do on the transmitter side before we get into forward programming on the flybar list system is the gyro. So let's go ahead and go into the gyro menu, and on this switch we want to change this from inhibit to flight mode. So as you can see here, we now have flight mode selected. And for all of these percentage points, we want all of them to be 87%. This is basically an overall reference for the gyro for the tail on the FC6350HX, just to see an overall reference point on where to start. Of course, you can always tune it through PIDs through the flybarless system, but again, if you have resorted to that and there's still some kind of oscillation and you've gone through everything mechanically and the PIDs don't help, you can always check and lower or raise this overall gyro gain for that specific flight mode that you see necessary. So again, we are going to change all of these percentage values to 87. So we have normal at 87, we got stunt 1 at 87, and for stunt 2 we can go to 87. And lastly, for hold, we can change this to 87. And now that all of these flight modes are set to 87%, we can go back to the list and go back to the main menu. We can now bind up the Blade Fusion 700 to this model. The bind procedure on the Blade Fusion 700 is a two-step process, so we will need to bind up the SRXL2 receiver to this transmitter, and also we will need to bind up the DSMX remote receiver to the transmitter as well. First, we are going to go ahead and bind the SRXL2. So all we need to do here is plug in the helicopter, press the button on the SRXL2, and as you can see, we have a flashing orange light, which means it is in bind mode. We can now go on the transmitter and go down to bind. Once again, just hit yes. One more time, just select bind. And as you can see, we have bound the transmitter and the SRXL2 together. And once the transmitter has configured itself for the telemetry, because we are running the Avian 200 amp ESC, which has the smart telemetry, we can now go ahead and unplug the helicopter. Now that the SRXL2 receiver is bound up to the transmitter, we can now bind up the DSMX remote receiver. And in order to do this, we need to unplug the SRXL2 receiver from the flybarless system receiver/program port, and we can now insert a bind plug into that same port, and then you want to make sure that the DSMX remote receiver is plugged in into its appropriate spot on the flybarless system. Once you have confirmed this, you can now power up the helicopter. As you can see, again, we have a flashing orange light, which means that the remote receiver is in bind mode. Again, we can go down to bind in our transmitter, and just like with the SRXL2, we can go ahead and bind it up. And as you can see here, we now have a solid orange light, which means the DSMX remote receiver is now bound up to the transmitter. Once this is complete, you can now power off the ESC, remove the bind plug from the flybarless system, and plug back in the SRXL2 receiver. Alright, so with the Fusion 700 bound up to the transmitter, we can now go ahead and adjust the telemetry alarms in order to suit the helicopter, and we can also input the right gear ratio, so then you get an accurate RPM reading from the main rotor. Now you can do this with the helicopter plugged in or unplugged. You just want to make sure that the telemetry auto-configured itself. So in this case it did, and I unplugged the battery from the Fusion 700, so it's not plugged in at the moment. So we can go down to telemetry right here, and as you see, again, it auto-configured itself. So the first thing that we can select is our smart battery. So we're gonna double click that, and in here, we want to make sure that our startup voltage minimum is 4 volts per cell. And once we have confirmed that, we can go ahead and back out. And this is where we can go to Smart ESC. We can go and make sure that the total cells is 12, since this is a 12S setup. The low voltage alarm is at 3.4 volts per cell. The amps max we can leave alone as well. Same thing with the temperature. Now once we get down to the pole count of the motor, we can enter 10 because we have a 10 pole motor on there. And for the ratio, since I installed a 12-tooth pinion on the motor, we can change this to 9.33 to 1. And as you can see, that will now give us the correct ratio, which in turn will give us a correct RPM reading from the rotor. Now, if you are running the 11-tooth pinion, you can change this to 10.18 like you see here. But again, the helicopter that I'm using has the 12-tooth, so we're just going to put that back to 9.33. And that's essentially all that you have to do in order to set up your telemetry alarms. One other thing that we can do at this moment, now that we've bounced the helicopter up to the transmitter, is set up the Avian ESC. Now that's super easy to do with the Spektrum transmitter and the Smart ESC like you see here. So all you have to do is plug in the helicopter, go over here to the transmitter, scroll all the way over to go to the Avian program menu. And again, step 1 is going to be low throttle, up elevator, left aileron like you see here. Now that we're at step 2, hold down up elevator and right aileron. And as you can see, we are in the Avian program menu, and you can navigate through the menu options with your elevator stick, and then you can make adjustments through the aileron stick. So for example, the flight mode, we want heli store gov, just like that. Brake type, we can leave it disabled. Brake force can stay at 0. Cutoff type, we want soft cutoff. Going down to LiPo cells, we can leave that at auto calculate. Cutoff voltage, we can change this down to 3 volts, or essentially whatever you want the soft cutoff to engage at, depending on your battery voltage per cell. BEC voltage, if you're running the servos with the super combo, they can handle 8.4 volts. If you're not running those servos, check with the maximum voltage that you can use on those electronics. For startup time, we can keep it at soft. Timing can stay at 15. Motor rotate, if you need to reverse the motor and you don't want to do it manually with the wires, you can change this to counterclockwise. For this, we just want to leave it clockwise since I have it set up correctly with the motor wires. Active freewheel, we can go ahead and just enable this. Governor gain, we can leave it level 1. Auto restart time, so the AR time, this essentially is how long you want your auto bailout to be active. Personally, I don't like having a bailout, so I'm just going to keep it at 0 seconds, which essentially disables it. Now the restart acceleration, since this is at 0 and disabled, this doesn't really matter what we have set to it, but just keep in mind if you are running a auto bailout time, this restart acceleration is going to pertain to the AR time. Thrust reverse, we can just change this to channel 8, and all we have to do is exit with save, and the Avian ESC is now set up for the Blade Fusion 700. Now that the helicopter's powered on, we can go ahead and go to our function list, and now you will see forward programming because the transmitter is bounced up to the SRXL2. If the transmitter is not bounced to the SRXL2 or the helicopter is powered off, then you will not see this forward programming option. So selecting the forward programming, you can now see that we have access to all of the parameters that we need to set up the FC6350HX with. And you don't even have to hook it up to a laptop or anything. It's all just through the transmitter. So going down to setup, the first thing that we're going to set is our swash plate, basically telling it our frame rate and also our swash plate type. And in order to do that, we're going to go from setup to swash plate like you see here. Output setup, and the frame rate, since we are using the Spektrum H6350s, we are going to select 333 Hertz. Now that the servos know their frame rate, you can see that they initialize, but we don't have usability over them just yet. You can see that I'm moving the collective stick and it's not wanting to move the servos. In order to move the servos, we have to go to our type right here, and we want our swash type for the Blade Fusion 700 to be 3 servos, 120 degrees, like you see here. Going back, you can now see that we have control over the cyclic servos, but you see that the swash plate isn't wanting to collectively move up. As you see, we have servo B and servo C both moving up, but servo A over here is wanting to move down. So we need to go ahead and change that, and in order to do that, we are going to go to our direction. So with the direction menu, you want to refer to your diagram, but essentially servo A is going to be channel 1, so this one right here. Servo B is going to be the back servo, which is output channel 2, and servo C is going to be output channel 3, and that's going to be this servo right here. We want to reverse this servo, so then all of the servos want to move the swash plate up whenever we give it positive pitch. And in order to do that, what we are going to do is go down to output channel 1, and we are going to reverse that. Now you can see that the swash plate collectively moves up and down. Now that we have that set, we want to go back, and this is where we can set up our sub trim. So this is essentially centering all the servos. Again, you want to make sure that your control linkages are the correct length as per the manual, and once you have verified that, then you can sub trim the servos. You don't want to sub trim the servos whenever it's something you could adjust mechanically. But since we have all the servo arms as close to 90 degrees as you see here, the fine tuning that we will have to do will need to be through the sub trim. So making adjustments to each servo, you want to make sure that the servo arm is 90 degrees perpendicular to the actual servo case like you see here. And this in turn will essentially give you a centered swash plate. If your swash plate is still not level after centering your servos using sub trim, you can mechanically adjust the control linkages. Now that the servos and swash plate are centered with the sub trim, we can stay in the sub trim menu and slide on the pitch gauge. Note that you want the helicopter blades parallel with the helicopter. Since you are in the sub trim menu through forward programming, your collective stick is defaulted at 50%. So that means that the helicopter blades should be neutral. So you want to adjust the flybarless linkages to the point where you see 0 degrees on the pitch gauge. Once you have acquired 0 degrees pitch on one of the blades, you can remove the pitch gauge, install it on the other blade, and do the process over again. Now that both blades are at 0 degrees pitch, which essentially means that the blade should track straight, which is what we want, we can go ahead and leave sub trim, and at this point we can also go back, and here is where we want to go to our AFR. Now that we are in the AFR menu, you can see that we have full control over the cyclic servos, and this is where we want to test our direction. So whenever we push up on the stick like so, you want to see the swash plate move forward. Whenever we pull back, you want to see the swash plate dip back. Whenever we move the aileron to the right, you want to see the swash plate dip right. And whenever we move the stick to the left, we want to see the swash plate dip left. Now, let's say that the roll was reversed. Essentially, all you would have to do is go all the way down to the other side. So as you see, we have negative 75 degrees in here now. So that means whenever we move the stick to the right, the swash plate wants to move to the left. And obviously this is not correct, but essentially what we would want to do is change this to a positive or negative value depending on which way we need to adjust the cyclic. So as you see here at 75 on the AFR, the cyclic moves the right way, or basically I should say a positive value moves the swash plate the correct way. Now that we have verified that the swash plate is moving the correct way in all directions, it is time to adjust our travel. Now for the cyclic, we want to see 12.5 degrees for the roll and 12.5 degrees for the pitch. Now that being said, we can go ahead and adjust these values through the numbers right here. So for a roll, we want to move the cyclic stick one way and adjust the roll value until we see 12.5 degrees on the roll axis. Keep in mind that you want your left stick or your collective stick to be centered during this process. Once you have the number plugged in on your roll that gives you 12.5 degrees of cyclic throw, you can go down to the pitch and do the same process. Now that we have 12.5 degrees of cyclic for both roll and pitch, we can now do our collective. Now on this one, you will want to give full positive pitch, and this is all personal preference. Typically I like to run about 13.5 degrees, so that is going to be my target value. So as you can see here with my collective AFR value, at 48 I get about 13.5 degrees of pitch. I can now go down to full negative, and as you see here, I have about 12.8 degrees of pitch. So that is whenever I can go to differential right here, and I can give it a negative value in order to increase the negative pitch, so then it is also negative 13.5 and essentially even on both sides. Now that we have our AFR value set, we can select back, and now we can set up the tail rotor. So going into the tail rotor setup menu, we can go to output setup, and again we want to select our frame rate. Since we are using the FC6350HX tail servo, we want to change this to 560 Hertz. As you can see here, we now have our tail servo set. We can now go to our direction. Now that we are in the direction menu, we can move the stick to the left, and as you see, this slider here moves to the left with the stick. This is essentially what we do not want, so we want to go ahead and reverse the tail rotor. So as you can see, it is now moving in the correct direction. Backing out of the direction menu, we can now go into the Spektrum menu, where this is going to center up the tail servo. And again, we can adjust the servo arm as necessary through the subtrim, and then once that is centered, we can mechanically adjust the tail control rod until the slider is parallel with the tail case right here. And with the subtrim value of -40 and a mechanical adjustment of the tail control rod, we now have the slider parallel to the tail case. Backing out of subtrim, we can now go to travel. And this is where we can see if there's any binding in the slider or the servo or anything like that. And my recommendation is, if there is no binding whatsoever, to just leave these values at 100. After verifying that there is no binding, we can go ahead and back out of the tail setup. Back at the main menu, what we are going to do now is input some starting values for the PID settings. Now, these have been tested by myself and some other pilots, and we have determined that these seem to be the best starting points. Again, they can change depending on many factors such as density, so what altitude you're at, essentially the humidity, temperature, some things like that, just to keep in mind. But yeah, first we are going to go into the roll setup, and for the PIDs to start off, we are going to go to 45 for the P. For the I, we are going to set this to 70. And for the D, we are going to lower this to 5. The degrees per second is all personal preference. I'm going to leave these at 300, but I do recommend going to around 250 or so just to start off. Going back to pitch, we can now input for P, we can put 65. I, we can change to 85. And D, we can set to 20. Once this is set, we can go back. And we have confirmed that agility is 80, that is the default. We can just leave that there for now to start off. Going to the tail rotor, again, the degrees per second is all personal preference. We recommend starting off at 515 degrees, so we can go ahead and lower that to 515 just to start off with. For the start, we want 20. For the stop, we want 20. For the P gain, we want 85. For I, we can bump this up to 150. And for D, we can leave this at 10. Back at the main menu, we can set up our failsafe for throttle. So basically, if something were to happen and the transmitter lost connection to the receiver, the throttle would default itself at the failsafe that we set. So we are going to go to Setup, go down to Throttle, Failsafe, and make sure that you are in hold mode, which you should be if you are in forward programming, and just hit Capture Failsafe Positions. And it is now complete. So now if something happened, the throttle would automatically put itself at 0% throttle. Backing out of the throttle menu, the next thing in the setup that we need to do is our orientation. So the gyro settings, we can go ahead and select this. We'll select orientation. And again, you just want to make sure that the logo on the transmitter is matching up with the logo on the FC6350HX. So we are going to select orientation 1 like so. Again, if you need to, you can change the orientation however you may need, but for this instance, we want orientation 1. And whenever we select back, it's going to ask us to calibrate the sensor. Now what you want to do with this is take a bubble level and set it on the FC6350HX and make sure that that bubble is level. You can adjust the helicopter however you need in order for it to be nice and level. And before you calibrate the sensor, because it is really sensitive, you want to remove the fan from the ESC in case it is creating any small vibrations. Once you are ready for the sensor to calibrate, you can select Begin. You will see a yellow flashing light on the flybarless system. It's going to flash a couple times, it'll do a rapid flash, and it will let you know on your transmitter whenever the calibrate sensor setup is complete. Once it is complete, you can select back, and that is all you need to do. Once you are at the forward programming main menu again, you can pick up the Blade Fusion 700 and move it around in order to verify that your orientation is correct. It should allow the swash plate to want to stay centered, as well as the tail pitch slider wanting to stay centered like so. After confirming that the flybarless system is correcting in the right direction, you can go ahead and exit forward programming. And just like that, everyone, the FC6350HX flybarless system is all set up, along with the Avian ESC being properly programmed, and now the Blade Fusion 700 is ready for its first flight. Thank you all so much for watching. Hopefully you get to see with not just how it builds, but also how it sets up, just how easy the Blade Fusion 700 is on a first ever kit builder, and also somebody who may have never set up a helicopter before. Again, thank you all so much for watching. We hope you all enjoyed the Blade Fusion 700.